In this follow-up, we're going to take our same hypothetical student who doesn't have a particularly good chance, 31% chance, of passing their final exam. We'll ask a related question on what grade or what range of grades do we think the student can expect to get based on this kind of historical distribution of assignments. So this, again, is a related question, and it's very much related to the idea of a confidence interval. So if we just kind of visualize what a confidence interval looked like, let's use green instead. We started at the mean, and we went out a certain distance equal to the critical value, and we went back a certain distance, the same distance actually, which corresponded to a negative critical value. And there was a set probability that the mean fell within this particular range. So often we would say there's a kind of a 95% confidence level that the mean would be in this range. Now it is important to know that the mean we're talking about here is a population mean. It's not a sample mean, not for a confidence interval. So by definition, the confidence interval talks about population means. And that means this distribution has to be of sample means, and this 50 would be a population mean. So everything's in populations. In our particular example, this is not a distribution of means. This is a distribution of observations. So we can still talk about intervals. Let me go get rid of some of this stuff. Oh, that didn't do it. We can still talk about intervals, but this is no longer a confidence interval because we're putting an interval around a sample mean. Confidence intervals have to be a population mean. All we have is the sample mean. That said, the ultimate procedure is going to be very similar. We're still going to start at the mean, and we're going to move over a certain distance above the mean that will give us, so if we're looking at a 95% confidence, not a confidence level, 95% threshold here, we're looking at 95% of the data, we're going to have 5% left, and so there's going to be 2.5% on this side, so that will extend a certain distance off to leave 2.5% of the curve over here, and it'll extend some distance off to the left such that 2.5% of the curve is going to be left on the outside of it, and then 95% of the curve will be in here. Again, and you can catch that I made a mistake and then caught it. This is not, again, a 95% confidence interval. This is the interval that will contain 95% of the observations. So let's calculate this. Our center point is the sample mean. We already have the sample mean, so that's where it's going to start. And then we need to calculate some distance such that we'll have 2.5, there is a decimal point in there, that will have 2.5% of the curve over here and 2.5% of the curve over here. This is also something we can do in Excel. Let's perhaps call this let's call it an interval. How's that? Not very exciting, but it'll work. So the upper part is going to be equal to, well, first we should really go calculate the distance, and then we'll get to the actual interval part. So how far do we need to go in order to have 2.5 left? So this is kind of similar to a critical value. So the critical value in our hypothesis test, we drew the line such that the area under the curve was equal to an alpha level, for instance, so 0.05 or 0.25, we'd have another one over there. So that was what the critical value was. Really, we're still defining a critical value. We want to draw a line such that we have a certain probability on the outside. This is going to be based on the t distribution, so let's just start typing a t and let Excel refresh our memories on what functions we have available. We want a distance. We do not have a distance yet, so it's not going to be one of those. We want a distance, so we're going to use one of the inverse functions. And there happens to be one, .inv two-tailed. Well, we're doing a two-tailed equivalence, not really a hypothesis test, not a two-tailed test per se, but we're still doing two tails or calculations with two tails, and we have our two tails here, so sure, let's go use that function. It asks for a probability. The syntax, the function's a little weird here in that it needs the total probability on either tail. So we'll just use our default for this, 0.05. Even though we want 2.5% on either side, we need to give it the whole probability, and that 2t means it will divide it in half for us. And the degrees of freedom is still number of data minus 1. So 5 data points minus 1 is 4 data points. So this tells us that if we were to start at the mean, and for this function, it doesn't matter if we're starting at a sample mean or a population mean. If we start at the mean and move over 2.78 standard deviations, then we will have 2.5% of the curve remaining over here. That is what that means. Great, so that is our distance. And now we have all the information we need for our interval. So let's do our interval upper bound. So this will be the highest value in original data units, the highest actual grade that our student could expect to get within 95% confidence. So this is equal to the mean. That's our starting point in the middle. And we're talking about upper bound, so we're going to add to it the distance that we have to move across, and that's in standard deviation units. Well, our mean is in original data units, our critical values in standard deviation units. The two don't match, so we have to do a unit conversion. So we're going to convert the critical value, the standard deviation, into original data units by multiplying by the standard deviation. So in the t-score, we started with our mean and our distance. We had to divide by the standard deviation. Now we're starting in standard deviation units, and we want to end up with the mean units of the mean. So we're going to multiply by the standard deviation. So we do that, and we get an upper bound of 57.5. This is an interval, so we have both an upper and a lower, two numbers. And so this is going to be equal to the mean, which is still our middle point. And for the lower bound, we're going to subtract the distance that we have to travel, but that's in standard deviation units. We need to do a unit conversion based on the standard deviation. So we'll multiply, and that is our lower bound. So the most likely grade that our student would expect is the mean. So they're probably looking for a 48, somewhere around there. And they can reasonably expect, reasonably being 95% confidence, to get between about a 57 and a 39. Yeah, so there's again a chance they will pass. We calculated that earlier, 31% chance that they'll pass, but probably not getting into the 60s, and maybe as low as something like a 40. So things are not looking particularly well for our student. Hopefully that helps. Again, this is not, it's what we did is very similar, in fact, pretty much exactly the same as what you would do to calculate a confidence interval. And although this is an interval and we have a confidence level, because we're talking about a sample mean and not a population mean, this is the distribution of observations of data points. Even though we do things the same, this is not technically a confidence interval. So something to not get confused on. Okay,